This is Module 1, Part 1, Chapter 1. Alright, and here we're going to talk about just chemistry being the central science, and then we're going to start talking about matter. So chemistry is the science of matter and the changes that it undergoes. Okay, and so we can look around and appreciate the impact of chemistry on technology and society. In the earliest days of civilization, when the Stone Age gave way to the Bronze Age, and then to the Iron Age, people didn't even realize that they were doing chemistry when they changed the material they found as stones into metals. The possession of metals gave them a new power over the environment. Civilization emerged as skills in transforming materials grew. They could now make glass, jewels, coins, and weapons, which became even more varied and effective. None of this would have happened without chemistry. So the development of steel, which accelerated the profound impact of chemistry on society, and better steel led us to the Industrial Revolution. And none of that would have happened without chemistry. And then in the 20th century, and now even into the 21st, came enormous progress in the development of the chemical industry. Chemistry transformed agriculture. Now we have synthetic fertilizers, which provide the means of feeding growing populations of the world. It's transformed communication and transportation. It provides advanced materials such as polymers for fabrics, ultra-pure silicone for computers, and glass for optical fibers. It is producing more efficient renewable fuels and the tough light alloys that are needed for modern aircraft and space travel. Chemistry has transformed medicine. It substantially extended life expectancy and provided the foundations of genetic engineering. None of this would have been possible without chemistry. So when we talk about chemistry, chemistry is the central science. It has implications in all major fields of science. Chemistry is an integral part of life, thus plays an important role in biology and biochemistry. We are constantly synthesizing and consuming different molecules inside our bodies. The pharmaceuticals we take to cure different sicknesses and disease relies on chemistry. So chemistry is really a daily part of our lives. From the time you wake up in the morning to the time you eat breakfast, brushing our teeth, till the time we go to bed, we are consuming different chemicals, using chemicals, and producing chemicals every day. Thus, chemistry is really just an important part of our lives. And so chemistry plays a role in physics, plays a role in environmental science, plant science, astronomy, geology. Okay, and so chemistry we can really think of as the central science. When we talk about chemistry, there's really 5 major branches. At UNF, we have chemists that are specialized in each field. So I encourage you to work in one of those labs to gain experience and see firsthand the day-to-day activities and research. Okay, and I'm going to be honest, it's also a very important addition to your medical, dental, or pharmacy application. So what are these major branches of chemistry? Well, first is organic. Organic is just the scientific study of the structure, properties, composition, reactions, and preparation of compounds. Okay? When we talk about organic compounds, we're talking about carbon-based. There's inorganic chemistry, which is the scientific study of the structure, properties, composition, reactions, and preparation of metals. We have analytical chemistry, which is just the study of natural and artificial materials. Physical chemistry is kind of where physics meets chemistry. And biochemistry, which is the chemistry of life. And I'll be honest, it's the best one. It's the favorite because that's what I do. There's other branches like geochemistry, astrochemistry, radiochemistry, medicinal chemistry, and others. Okay? But I just wanted you to be aware of the different major branches of chemistry. So, why should you think about having a major in chemistry? I'm not here to persuade you to choose chemistry over biology or whatever other majors you might be in. But there's a lot of things you can do with a major in chemistry, and one of the things is it does stand out on an application to some of these post-baccalaureate programs. But you can be an analytical chemist, you could work at Coca-Cola, helping try to design new bottles and so forth. You can be a biochemist like me, you can study drug design, you can try to make new drugs to treat different diseases. You could become a chemistry professor and teach other freshmen and sophomores, juniors, or whatever about chemistry. You can be a food chemist. That's pretty popular. You can help design makeups. There's a lot of things that you can do as a chemist, okay, or having a major in chemistry. So, the last little bit before we really start getting into the material is how should you study for this chemistry class? Okay, first is don't be intimidated. Okay, you really need to work on learning the material. Okay, it's like learning a foreign language. You have to practice it. Okay, it's the only way. you can't memorize everything. If you just try to memorize everything, you'll never end up understanding what's actually happening and how to make different calculations. So understand the concepts. Don't fall behind, especially in an online class. You have to stay on top of the material. Once you're behind, it's hard to catch up. Make sure you read ahead, make sure that you're always up to date on the reading. And the number one thing in order to pass a chemistry class is practice. Practice, practice, practice. Okay? And don't forget that. Alright, so what is chemistry? Well, chemistry is a science in which we study matter, its properties, and its behavior. And so we can talk about each one of these. When we talk about chemistry, it's the study of matter and the changes that matter undergoes. Well, matter is anything that has mass and occupies space can be defined as matter. It could be gold, right? It could be our textbook. It could be a glass of water. These are all different types of matter, okay? And the properties, which are characteristics that allow us to recognize a particular type of matter and distinguish it from other types, can be used to describe these, okay? We can talk about a textbook or a piece of gold as a solid, right? Water is a liquid. So these are different properties that define and recognize different types of matter. And all known matter is composed from combinations of about 100 elements or so. And we'll talk about these different elements. So when we touch, pour, even weigh something, then we're working with matter. Okay? Matter is just the physical material of the universe. So really we can think of matter as just a bunch of elements that are combined together. So if we took matter and decided to cut it up into its simplest form, okay? So we took our textbook, we cut it up into the simplest form possible. What we would find is atoms. And each element is composed of only one atom. And so when we talk about atom, it comes from the Greek word, which means not cuttable. Okay? So it's the simplest form. So atoms are the building blocks of matter. Okay? They are the smallest particle of an element. And we can talk about two different things. One is an element. Okay? An element is a substance composed of only one kind of atom. And if we take a look at this first picture, here we have atoms. Okay? Each one of these balls, okay, which is an element, okay, these are the same element, they're the same color, and in chemistry, which you'll see throughout this course, basically each atom of an element is designated as a spherical colored ball, okay, and so here we have 6 different atoms of the same element, okay. We can also have a compound, okay, and a compound is made of 2 or more different kinds of elements, okay, and so we can see that here, where we have a purple and a green ball. Those are composed together, and so it's a compound. It's made of 2 or more different kinds of elements. Okay, so like I said, throughout the textbook in this class, you'll see different colored spheres or balls which designate different atoms of an element. Okay, and in most cases, you're going to see carbon's usually a black ball, oxygen is red, nitrogen is blue, hydrogen is usually white. So, small differences in the structure or composition can change a molecule's properties. Okay, for example, if we look at ethanol, which is shown here, okay, ethanol is in many delicious beverages, right? Beer and wine. And it's consumed by many individuals over the age of 21 and nobody below that, right? Of course, you would never be doing so. So, if we actually compare this to ethylene glycol, okay, which is shown down here, ethylene glycol is a viscous liquid. It's used in automobile antifreeze and extremely toxic. Okay, but what you see is that it's pretty much composed of the same types of elements, but based on the structure and the composition, it has very differing effects between ethanol and ethylene glycol. And so chemists use this, and they alter the structure and composition of different compounds to change the properties of those compounds. Alright, so we can actually see matter, and we talk about matter in 2 ways. One is the macroscopic way. The macroscopic way is when we talk about water droplets. We can see those droplets. But what's happening at the submicroscopic is that we have these different compounds and different elements, different atoms that are, make up this water droplet. And so when we talk about chemistry, chemistry seeks to understand the properties and behavior of matter at the submicroscopic level. Alright, so we can classify matter by its physical state and its composition. When we talk about the physical states, we're talking about as a gas, a liquid, or a solid. Okay? So, If we take a look at the physical state, first in a macroscopic view, okay, first we can look at a gas. Okay, a gas has no fixed volume or shape and is compressible, and so it's going to conform to the shape of the container. You can think of a propane tank, which is filled with propane gas. It fills up that entire container. We have liquids which have a distinct volume that is independent of the container's shape, and there is no fixed volume. Okay, so liquid takes the shape of the container it occupies. Think of a glass of water, right? It fills the entire glass. And last are solids, which are definite shape and volume. They're rigid, they're incompressible, and we can think of ice. Alternatively, we can look at the microscopic or that molecular view, where we're thinking about what's happening with the molecules in these atoms. With a gas, the molecules are far apart. They move fast and they collide often. Liquid molecules are moving rapidly, but they actually just slide over one another. And solid molecules are packed closely in a definite arrangement, okay, and they can't really move around. Alright, we can also classify matter by its composition, okay, and basically, a substance is just a single pure form of matter, okay, it has distinct properties and a fixed composition. So all substances are either elements or compounds. So composition of matter can either be defined as an element, which means it can't decompose into simpler substances, okay. There's 118 elements designated by symbols on the periodic table. Each is given a unique name and a chemical symbol, and these elements can vary in abundance. Compounds are substances composed of two or more elements. The properties of the compound differ from the component elements. So a combination of atoms to form compounds change the properties of the compound. Okay? And we can see this by comparing the properties. Water is a liquid, right? Water is made up of 2 hydrogen and 1 oxygen. Okay? But hydrogen and oxygen alone are gases at the same temperature and pressure. And so you can see how the properties change by combining these 2 or more different elements. So matter can also be composed of a mixture. When we talk about a mixture, it just means that you have a mixture of different substances, different elements, and different compounds. So it's a combination of 2 or more substances in which each substance retains its chemical identity. The substances in a mixture are called components. Okay, so mixtures have variable composition. So if we look at an example of the compound, we said water is always composed of 1 oxygen and 2 hydrogen atoms. A mixture is something like sweet tea, sweet coffee, sand, right? You have a mixture of different things, maybe sugar and water, maybe sugar and tea. You have sand, which is made up of different compounds. And so we can actually divide these types of mixtures, or divide mixtures into 2 different types. Heterogeneous mixtures, which are not uniform throughout. Okay, the composition, properties, and appearance differ throughout. These are things like rocks, wood, cookies. Okay, and we can also think of things like salad dressing, right, or a salad, or a bag of M&Ms. These are heterogeneous. They are not uniform throughout. You can have homogeneous mixtures, which are uniform throughout. Okay, these are things like seawater, different perfumes, sweet tea, coffee, the air. Okay, these are homogeneous mixtures. And so we can actually use this table to help classify matter. First, we can identify what type of matter we have. Then we can ask the question, is it uniform throughout? Okay, if it's not, something like salad dressing, then you have a heterogeneous mixture. Okay. However, if it is uniform throughout, then we can say it's homogeneous, and then we can ask the question, does it have variable composition? Which means, does the composition from one sample to another differ? If it does, then you have some kind of homogeneous mixture, a solution. Okay? If it does not have variable composition, meaning that it is always the same, then you have some type of pure substance. And those substances can then be separated into 2 different types, right? We could either have an element or we could have a compound. And so if I gave you some type of matter, you should be able to use this chart and know this chart in your head in order to solve for what it's actually made up of. Alright, so now we can look at the properties of matter in chapter. So there's really 2 major types of properties, physical properties and chemical properties. When we talk about physical properties, these can be observed without changing a substance into another substance. Things like the boiling point, density, mass, volume. Chemical properties can only be observed when a substance is changed into another substance, such as flammability, corrosiveness, reactivity with acid. And these can actually be broken down more when we talk about intensive and extensive properties. An intensive property is independent of the amount of substance that is present. The density of this object, the boiling point, the color, isn't going to change based on the amount of substance. If you have a little bit or a lot, the density, boiling point, and color are going to be the same. Whereas when we talk about extensive properties, it actually depends upon the amount of substance present. Things like the mass, the volume, the energy. Okay, depending on how much is present, those are going to change. We can also talk about the different types of changes. So we can talk about physical changes or chemical changes. When we talk about physical changes, we're talking about the change of the state that the matter's in, the temperature, the volume. And so the easiest one to think of is water, right? It can exist as a liquid, it can form an ice when it's frozen, or it can produce steam. Those are all physical changes. But we can also have chemical changes, such as combustion, oxidation, decomposition. And we can see that with dropping a penny in nitric acid. The dissolved copper produces a blue-green solution, and the reddish-brown gas produced is nitrogen dioxide. So here we actually have a chemical change. The last thing I want to talk about today is separation techniques of mixtures. And there's three major types: filtration, distillation, and chromatography. So the first is filtration. Filtration is basically just taking a funnel and separating a solid from a liquid. Okay, so basically the solid substance is collected and stopped by the filter while the liquid can pass through. Okay, and you'll do this in Gen Chem lab. The second is the distillation, which is you probably do more in organic chemistry, and it uses differences in the boiling points of substances to separate a homogeneous mixture into its different components. And so basically we can start out by taking our solution and putting it in a volumetric flask. Basically you heat that to boils so that basically water goes up and is transferred down this column. This is a distillation column. Water is collected in the receiving flask, so as water is cooled, basically you have the water vapor, which comes as a gas out, goes down this column, and that has water being pumped through to cool that water back down into the liquid, and that liquid is then collected into the other volumetric flask. Okay, and that leaves us pure sodium chloride in our original volumetric flask. The last method is chromatography, where basically you can separate substances on the basis of differences in solubility in a solvent. I don't really want to go too much into this, but basically you spot your sample on some type of specialized paper, you put that into a solvent, and that solvent travels up the paper, okay, and it carries the different components of this mixture to different spots. And so that's what we see here is a number of different substances. Alright, that concludes part 1, module 1.